Which of the following is not a function of the network layer protocol, that is internet protocol? Some 4 statements were given. Among this, we need to find out the statements which are not a function of the network layer protocol. A. Determining network layer addressing. B. Determining the route of a datagram follows from source to destination. C. Determining datagram format. D. Reporting errors in datagram. So actually, if you take determining network layer addressing, addressing is a major concept of the network layer because it has to decide the logical address of a host. So it is a part of network layer protocol. And determining the route of a datagram follows from source to the destination. It is also sometimes source has to set the route, that is, the source routing packets will be there. In the optional field of the header, we can have strict source routing packets and loose source routing packets. So sometimes it may be given the list of routers that are to be visited compulsorily, that is called strict source routing. That is why source routing is also, determining of the source routing is also a part of the network layer. And C is determining datagram format. The format of datagram is also determined by the IP protocol, that is in which format it will be in and all. And then option D is the reporting errors in datagram. If there were any errors in the datagram, it has to report the errors. So all are the functions of the network layer protocol. So in option A, it is saying that B and D only functions. Which of the following is not function of the network layer? All are functions, so that's why none of these is the correct option. Because in option A it is saying that B and D are not the functions, but B and D are the functions, because determining the route of a datagram follows from source to destination is also a task of the internet protocol when strict source routing is followed. And option D is the right option here, since all are the functions of the network layer protocol, that is internet protocol.
This question, 3 schedules, schedule 1, schedule 2 and schedule 3 are given, and we have to identify the view equivalent schedule of schedule 1 from schedule 2 and schedule 3. If schedule 4 is view equivalent to schedule 5, then initial read and final write operation on each data item should be done by same transaction in both the schedules. Let us say if in schedule 4, if T1 reads a data item A initially, then same thing should be happen in schedule 5 also, and final write operation should be performed by same transaction. And also intermediate read operation should be same. For example, if T1 reads the data item written by T2, then same thing should be happen in schedule 5 also. Then only these two schedules are view equivalent to each other. So here in schedule 1, initial read operations of data items A and B are performed by transaction T1. But if we see the schedule 2, same thing is happened. Here initial read operations on A and B are performed by T1. But in schedule 3, initial read is performed by transaction T2. So this cannot be the view equivalent schedule of schedule 1. In schedule 1, data items T2 reads the data items A and B which are written by T1. Same thing is happened in schedule 2 also. But that is not case with the schedule 3. And here final write operations on A and B are performed by transaction T2 in schedule 1. Same thing is happened in schedule 2. But that is not the case with schedule 3. So here schedule 1 is view equivalent to schedule 2 but not schedule 3. So here correct option is option B.
Here the question is, consider the following cross-coupled XNOR circuits with inputs W, X and Y and Z. Propagation delay of XNOR gate is 1 nanosecond and the initial values for the circuit nodes are W equals to 0, X equals to 0, Y equals to 0, Z equals to 1. The circuit behavior is to be determined when W equals to 1 and X equals to 0. That is, here, first of all, what we have to find out is the timing diagram of the timing diagram at the Y if W is changed to 1. So, if it is changed to 1, it was kept initially as 0 and now also 0. So, this change is going to appear here after 1 second. Yes or no? So, after 1 nanosecond, this is going to be, here is 0. Means initially it was 1, so it is 1. 1 means it is going to be 0. So it is an XNOR gate. If both inputs are 1, then the output is going to be 1. So this is the change for the first time the change in Y is going to happen after the 1 nanoseconds, because each having 1 nanoseconds. This change is going to appear here, and 1 0 means it is going to be 0 now. So this change again is going to happen here after 2 nanoseconds, means the figure for Y is nothing but in this way. Initially it was 6. In this way it is going to appear. Hence, this is the correct output for the figure Y. Now, here the Z is going to oscillate because the frequency of the Z is similar to the frequency of Y. So, the frequency of Z is equals to frequency of Y, which is nothing but 4 nanoseconds. Hence, option B is correct.